You ever wonder how your favorite app works? Or, what's really going on inside your computer? Well, today, we're going to demystify code. We're taking a journey from its ancient and kind of surprising origins, right up to the software that pretty much runs our world. And we're going to find out what it really means to speak the language of machines.
So, let's start with a riddle. What could an ancient mechanical flute and the smartphone in your pocket possibly have in common? I know it sounds weird, right? But the answer is a single, incredibly powerful idea that has been shaping human innovation for centuries: a program.
And really, when you strip it all down, that's all programming is. Think of it like the ultimate recipe. It's just a set of instructions, but they're so detailed and so precise that a machine, which remember has zero intuition, can follow them perfectly to get something done.
All right, so to really get a grip on programming today, we've got to go back in time. And you might be surprised to find out that this story doesn't start with silicon chips and screens. Nope. It starts with things like music boxes and fabric looms. The basic idea of programming is ancient. Over 1,000 years ago, the Banu Musa brothers built a mechanical flute that could play different tunes from a stored set of instructions. A few centuries later, Al-Jazari made a programmable drum machine. The big takeaway here is that for centuries, we've been fascinated with this idea of creating machines that can just follow a plan we write for them.
So this quote, it's about the amazing Ada Lovelace. Back in the 19th century, she was working on a theoretical computer called the analytical engine. And she wasn't just crunching numbers. She published the first real algorithm. But here's where she was a true visionary. She saw that the machine wasn't just for math. She imagined it could handle any kind of symbol, like words or music. That giant conceptual leap is exactly why she's called the world's first programmer.
So get this, the very first programs weren't text on a screen. They were physical objects. Take the Jacquard loom. It used these pasteboard cards with holes punched in them to control the pattern of the fabric. A hole meant the machine did one thing. No hole meant it did another. It was basically a physical form of binary code, a simple series of yes or no instructions that could create these incredibly complex designs.
And this whole punch card idea, it wasn't a one-off thing. It became the standard for decades. Early IBM computers were completely reliant on them. Can you imagine? Your job is to write a program by punching thousands of little holes into cards, and if you trip and drop the whole stack, you might have to start all over again.
Okay, so thankfully we're not dealing with punch cards anymore. Today, programmers write instructions, what we call source code, using a keyboard and a screen. The difference in speed and flexibility is, well, it's hard to even wrap your head around. A super complex program that once would have filled a room with cards can now be written, tweaked, and shared around the world in seconds.
But, okay, there was still this one huge problem. Computers only understand zeros and ones, machine code, which is incredibly tedious for humans to work with. And that's where the brilliant Grace Hopper comes in with a total game changer, the compiler. Think of it like a universal translator. It lets programmers write in languages that feel more like human logic, and then it perfectly translates all of that into the machine code the computer actually understands. This single invention blew the doors wide open for the world of programming.
All right, so we've got the tools, but what does it actually mean to be a good programmer today? Well, it's about so much more than just writing instructions that work. It's really become a craft, where things like elegance, clarity, and durability are just as important.
Yeah, a good program today has to juggle all of these things to be considered high quality. It's got to be reliable, giving you the right answer every single time. It has to be robust, meaning it can handle weird situations without just crashing, and it needs to be efficient, using as little memory and processing power as possible. Nailing that balance is the real art of it.
But of all those things, there's one that really surprises most people, and that's readability. Why on earth does it matter if the code is easy to read? Well, here's the thing most people don't realize. Programmers spend way more time reading and tweaking old code than they do writing brand new stuff from scratch. And if you can't figure out what the code is doing, you can't fix it, and you definitely can't improve it.
And that's why you got to remember, a programmer is always writing for two audiences. The computer, yes, but also for the next human who has to look at their work. Good code is like a well-organized library. It's easy to find what you need. Bad code, it's a tangled mess that costs a ton of time and money to try and untangle.
Okay, but let's be real. No matter how carefully you write code, it almost never works perfectly the first time. The process of hunting down and fixing all those little errors is called debugging. It's a huge part of the job. So why do we call them bugs?
Well, because the very first one was a literal bug.
This is a page from a logbook from 1947 where Grace Hopper and her team found their massive computer grinding to a halt. The cause? A moth had gotten itself stuck in a relay. They carefully removed it, taped it to the page, and wrote, "First actual case of bug being found." And the name just stuck.
So who are these people anyway? The architects of our entire digital world. What does a programmer's day actually look like?
A programmer's job is so much more than just sitting there and typing code. It's this whole problem-solving cycle. It starts with really understanding a need. Then you design an elegant solution for it, you build it, you test it like crazy, and then you spend years maintaining and improving it. The actual coding is just one step in a much bigger creative process.
So check this out. Back in 2014, the estimate was about 18.5 million software developers around the world. And today, that number has just shot through the roof. This isn't some tiny niche profession. It's a massive global workforce that is actively building the invisible infrastructure of our daily lives.
And the whole profession itself is changing. Learning to code isn't just for computer science majors anymore. Through all these online platforms and school programs, millions of people of all ages are learning this skill. They see it not just as a job, but as a really powerful tool for creativity and problem solving, no matter what field they're in.
So, all of this really brings us to a huge question for our time. As software keeps embedding itself into every single corner of our lives, is understanding the language of computers becoming just as essential as knowing how to read and write? Is learning to code basically the new literacy for the 21st century? It's definitely something to think about.